Without a telescope, you can see several thousand stars in the night sky, as well as a few hazy patches of light. Astronomers have studied these with powerful telescopes and learned that these are galaxies, systems that contain millions or even billions of stars. Most estimates place the number of galaxies in the universe from 50 to 100 billion. Space is so vast that most galaxies are millions of light years apart. The galaxy to which our sun belongs is the Milky Way, where it is one star among hundreds of billions. The Milky Way is a spiral galaxy, shaped like a thin disk with a central bulge. No two galaxies are exactly alike. Most galaxies are spiral-shaped, like the Milky Way. Some galaxies' shape are elliptical and vary in their eccentricity and contain very few young stars. Some galaxies are irregular in shape and are smaller and fainter than the other galaxies since its stars are spread unevenly. Now there are two types of galaxies. There's a normal galaxy, like our Milky Way for example, where the amount of energy it puts out is the same amount of energy that the stars make. Some galaxies, called an active galaxy, are going to emit more energy than the stars themselves produce, and some theories say that this is because of black holes. Galaxies are located in the universe. The universe is everything that exists. The observable universe is everything that we can observe. According to evidence collected by NASA, the estimated age of our universe is 14 billion years. Scientists can't say how the universe originated. However, by observing the galaxies and experimenting here on Earth, they have been able to put together a model of how it developed. This model is called the Big Bang Theory, and it doesn't explain how the universe started, but it explains the history of the universe starting a tiny fraction of a second after it came into being. The theory goes as follows. About 14 billion years ago, all matter in the universe existed in an incredibly hot and dense state, from which it expanded and then cooled, forming stars and galaxies. At first, the temperature was too hot for atoms to survive, but eventually the universe cooled down. As more and more stars formed, our solar system formed as well. There are two pieces of evidence for the Big Bang model. The first is the universe's apparent expansion. In 1929, astronomer Edwin Hubble found redshifts in the spectrum of the galaxies he studied. Now, if you remember from yesterday, that as a galaxy moves away, it's going to have a longer wavelength. If it's a longer wavelength, it's going to be to the red side of the spectrum. Since he found a redshift, this showed that the galaxies were moving away from Earth and the universe was expanding. The second piece of evidence that supports the Big Bang Theory is discovery of radiation left over from the universe's beginning, and this is called cosmic background radiation. So what does that mean? A cosmic satellite dedicated to exploring the origins of the universe found that the temperature of the universe was similar to what cosmologists had predicted. They predicted this by taking into account the amount of time the universe had to cool after the Big Bang Theory. And since this radiation matched that, this is evidence that points towards the Big Bang Theory. Now, it is impossible to know for certain how the universe began, but the Big Bang Theory model tells us what happened after it began. That's all you need to know for today. Please make sure to answer the questions in the form below. If you have any questions about what we did today, please send me a question in the Google Classroom and join me on Zoom. Thank you so much for watching. Have a great day.